Okay, this is the Secondary Math 3 Unit 3 review. I already started it, but I wanted to stop really quick to make sure my video was recording with sound, because I've made an entire video once without sound, and then that's a complete waste of time. So this is the Unit 3 review for your test next week. Just as a quick side note, I'm doing this in the middle of the day. My family is awake and in the background, so if you hear anything, it will probably be them. And I'm going to go through all of these problems, giving you what I would call a full credit answer. So number one, if I were asked to state the number of solutions, make sure you're reading all of the instructions on this, because the instructions will tell you exactly what to do. Anyway, this guy right here, if I want to know how many solutions this polynomial has, I need to look for the greatest degree in the polynomial. Now all of these are given to you in standard form. Make sure you're watching out to see which one is the largest exponent, because if this was a 14 instead of a 4, then it would not be in standard form and the answer would be 14, because that's the highest degree. So there will be 6 solutions because the degree of the polynomial is 6. Likewise for number 2, there are 42 solutions because the degree of the polynomial is 42. We should do synthetic division on that one. You want to? No. Okay, just kidding. All right, number 3, use the remainder theorem. Now, I don't exactly care if you remember what that is. You just need to know what to do here. So use the remainder theorem to evaluate P of 5. That's kind of the key right here. So it's telling us what to do. So I have this polynomial. There's 2 ways to evaluate a 5. You could either, and so number 3 and number 4 are the same type of question. I'm going to do one way and one the other. So if I'm evaluating when P is 5, that means I want to find where Y is when X is 5. So that's kind of the use one sentence to explain your answer, what your answer means. It's talking about where it is on the graph. So you could use synthetic division. I like synthetic division because I don't have to use a calculator as often. And here's how I would write my answer. P of 5 equals 71. This is the Y value on the graph when X equals 5. So that I would say is a full credit answer. The other thing you can do is, do you hear my child? The other thing you can do is plug it into the equation. So normally it would say like P of X, right? Which means everywhere there's an X, we're going to plug in a 2. I've never done a video with children in the background, so we'll see how this goes. I might be interrupted very soon. You can see my kitchen light right there. Okay, so I've got 2 cubed minus 5 times 2 squared plus 3 times 2 plus 6. I get 0. So what does that mean? So this means because I got a 0 here, this means that x equals 2 is a root of the polynomial. That means if I were to graph it, at 2, it's going to be going through the graph. I don't know what's happening anywhere else because we didn't find anything else, but it means at the 2 mark, it's a 0. It's a root. So feel free to use a picture to support your answer when you do your test. Number 5 and 6, I like how there are 2 questions on each type. So you can remind yourself on 5 and then practice on 6, but use the rational root theorem. Again, this right here, I don't expect you to know the definition, the rational root theorem. Like, what's that? I don't really care about that. But this I do care about. This is kind of like the indicator of what you're supposed to do on this problem. To list all possible rational roots. Unfortunately, these aren't very big numbers, so it's hard to get a lot of practice here. But if I want to list all possible rational roots, I need to start with listing the factors of p and the factors of q. P comes from the last number. Q comes from the first number. So p is 2, q is 1, right? The factors of p, I guess I should have written it a different way, are plus and minus 1, plus or minus 2, because that's everything that goes into 2. When I'm listing my p over q's, q is just 1, right? So 1 divided by 1, 2 divided by 1, and that's it. Now from this, state which of these ones are actually roots. So to do this, we got a 1, a 5, a -4, a -2. You could plug in 1, see if it works. Plug in -1, see if it works. Plug in 2, see if it works. Plug in -2, see if it works. And maybe I should do that since I'm writing in pen. Okay, yeah, I think I'm going to. Since I'm writing in pen, let's do it. Let's try 1. 1. So 1 cubed plus 5 times 1. I actually don't even have to plug in the ones there, right? Minus 2 times 1 plus 3 does not work. All right, -1 cubed plus 5 times -1 squared minus 4 times -1 minus 2, I get a 6. Let's plug in a 2. Did I screw up somewhere? Yes, hold on. 2 cubed plus 5 times 2 squared minus 4 times 2 minus 2. Okay, I'm going back up to this one. I think I got number 5 and number 6 is confused. So 1 cubed plus 5 times 1 squared minus 4 times 1. No, that was 0. So 1 should have worked. Sorry. That's what you get, right? Okay. 1 times 1, 6. 6, 2, 2, 0. Okay, so we know if we start listing x equals 2 is one of my solutions, right? X equals 1. Oh my gosh. X equals 1. Now from here, if the question said find all roots, we would have to keep going. But it says find all, which of these ones right here are solutions. Now if these are solutions, then this would have to factor. If I were trying to set up the factoring, I need 2 numbers that multiply to 2, add to 6. It's not possible, right? So x equals 1 is my only solution. If I needed to find all roots, I would continue on by using the quadratic formula. Okay, number 6. Again, the same thing. List the possibilities, and then which of those possibilities are actually roots. So the p-value comes from the 3, right? So plus or minus 1, plus or minus 3. The q value comes from a 2, so plus or minus 1. You actually don't need the plus or minus on the bottom, because when you do p over q, you have plus or minus. Let's do 1 over 1, 3 over 1, and then 1 over 2, and 3 over 2. So let's set up the synthetic division. First, does anything factor out? No. 2, 1, negative 4, negative 2, 3. All right, this was number 6. I remember Mrs. Wilkins said number 6 only had one rational root. And how in the world does that work? How in the world does that work if rationals are supposed to come in pairs? Or irrationals will come in pairs. Give me 1 second. I'm going to look at what this graph looks like on, I'm going to graph this equation really quick. If there was a pause button, I would pause it, but there's not. So bear with me for 1 second. Let's try 1. Huh, interesting. 2, 3, 3, negative 1, negative 1, negative 3, negative 3, 0. So x equals 1 is one of my solutions. Let's try 1 again. Don't forget you can have a root that happens twice. So this is a perfectly fine problem. I don't know where the confusion was. Oh wait, hold on. 2 times 1 is 2. Add, you get 5. 5 times 1 is 5. Add, you get 4. 4, you get 1. Interesting. So no 1. It looks like from the graph, I just kind of zoomed in, it looks like it's a double root at 1. But when you zoom in, it's not. So this is my 1 right here. It goes down, it crosses at an irrational place. It crosses through 1. So 1 is my first root. Interesting. Okay, so let's back up a little bit so I can show you the entire graph. So because it turns and goes back up right here, that means 2 of my solutions are imaginary. And then right here I've got 1 real and 1 irrational. It's interesting. I don't know why that works that way. So I guess x equals 1 is my only solution. Weird. Okay, weird. Number 7 and 8 are the same question. State the discriminant of the following quadratic equation. What does this discriminant tell you about the solutions of the equation? Well, off to the side, I'm just going to write down what the quadratic formula is. Hopefully we've done this enough that you know what the quadratic equation is. Now, what part of the quadratic formula determines what kind of solutions you have? It's all right here, right? If this number inside is negative, you're going to have imaginary solutions. If it's positive, you're going to have real solutions. If it's a perfect square, That means the square root goes away and the solutions will be rational. So let's see what happens. If the question's just asking for the discriminant, it only cares about the number inside the square root. So in this case, b squared minus 4 times a times c. Can you hear my kids fighting in the background? They are. So 2 squared minus 4 times 8 times a negative 8, negative 6, is 196. Now what does that mean? Well, 196, let's see if it's a perfect square. Probably should have these memorized. So it's a 14, right? That means inside my square root is a perfect square. So if I were setting this up, you don't have to do this for your homework, but if I were setting this up, it would be negative 2 plus or minus 14, right? Because that square root went away, and then all over 2a, all over 16. That right there is just a fraction, which means there are 2 rational roots. Number 8, state the discriminant of the following quadratic equation. So again, b squared minus 4 times a times c, 9 minus 48, it's a negative 39. So because that's negative, if I had a negative number inside of my square root, that means I'm having what kind of solutions? To imaginary. Okay, next page. Let's get moving. We don't want this to take forever. Find all solutions to the following quadratic equations. Now these ones are kind of special because there is no middle term. So all you have to do on this one, add the 49, take the square root. Now x equals 7, but because you put the square root on, it also would equal negative 7. That's how you get your 2 solutions. Number 10, subtract the 16, take the square root. Because you put the square root on, it will be plus or minus. The square root of 16 is 4. The square root of a negative number is I. Okay, number 11. Find all solutions to the following quadratic equation. Add the 11. Take the square root. X equals, you took the square root, plus or minus square root 11. Alright, next example, number 12. Polynomial with rational coefficients have the following zeros. Rational coefficients means there's not going to be any square root coefficients in your final answer. Find any remaining zeros. So this one right here, the 6 does not come with a match, right? 6 and negative 6 aren't necessarily on the graph together always. 6 and 5, they're both rational roots, so they don't have a partner that it comes with, but the 3i does. So the other root has to be a positive 3i. Now if I wanted to write a 4th degree polynomial, quick side note by the way, on the test it's just going to say write a, and that will be gone. Write a polynomial with rational coefficients that has those zeros. So here's how you would do it. So x minus 6, right? X minus 5. X plus 3i, and x minus 3i. Make sure you change the sign on all of those. X minus 6, x minus 5, x plus 3a, x minus 3a. And then let's multiply these two together. X squared, did you know to get the middle term, all you have to do is add those two numbers together? Sort of, if those are ones. So I've got a minus 6x minus 5x, right? So I'm just going to quickly minus 11x plus 30. Okay, right here, when I multiply those together, I've got an x squared minus 3i plus 3i, they go away, And then you're going to have a minus 9i squared. Well, I squared is a negative 1, so it's going to be x squared plus 9. Now I've got to distribute that back through. X squared times x squared is x to the 4th minus 11x cubed plus 30x squared, and then 9x squared minus 99x plus 270. Final answer, y equals x to the 4th minus 11x cubed plus 39x squared minus 99x plus 270. Hi. Okay, number 13, let's do it again. Does the 4 have a partner? No. So x minus 4. And then square root 3 minus square root 3. But the square root comes with a partner always. The rationals and the imaginaries do. Hey J-Man, will you tell Dad that Bear needs to go outside? Oh yeah. Bear, you're gonna have to wait. Sorry. Nope, get down. Okay. So let's hang off to the x minus 4 really quick because this is a difference of squares. So x times x is x squared. X times the square root of 3 is going to be plus the square root of 3 minus the square root of 3. And then the square root of 3 times the square root of 3 is minus 3. It's called a conjugate pair. And that just, that just basically means all of the square roots go away. These would be conjugate pairs because all of the i's go away. Okay, now let's multiply the x through. X times x squared is x cubed minus 3x minus 4x squared plus 12. But I don't want to leave my final answer like that because just get in the habit of putting it in standard form. All right, factor the polynomial completely and find all zeros. So, two answers here. One, we have to factor it. I'm going to first look to see if I can factor by grouping. On this one, I'd be able to pull out an x squared. On this one, if I pulled out an 8, would I be left with 6? Yes, so this one factoring by grouping works. Otherwise, you could use the synthetic division. Alright, so x squared, x minus 6, plus 8, x minus 6, x squared plus 8, times x minus 6. Now this cannot be factored further because of the squared and the plus sign. I mean, if you try to factor it, we need to find two numbers that multiply to 8 and add to 0. It's not possible, right? So I can't factor this further, which means this is my first part of the answer. Now to get my second part, then find all zeros, set each of those equal to 0. X minus 6 equals 0. X squared plus 8 equals 0. So x equals 6. Subtract the 8. Take the square root. Now 8 breaks up, right? To 2, 2, and 2. So how would I rewrite this? Instead of saying the square root of negative 8, I'm going to say x equals 6 and plus or minus, because you took the square root, and then 2 comes out. The negative comes out as an I. My loner 2 stays in. Okay, moving on, number 15. Let's do the same thing, factor it. On this one, if I pulled out the 4 and the x squared, I'm going to have x minus 3. If I pull out a 9, I have x minus 3. So let's factor by grouping again. both have an x minus 3. 4x squared plus 9 is left. So this is factored completely. I had to squeeze that 4 in because I forgot it. Now if I wanted to solve, x minus 3 equals 0. 4x squared plus 9 equals 0. So x equals 3 from here. 4x squared equals negative 9. X squared equals negative 9/4. Right, divide by 4, take the square root. So plus or minus square root of 9 is 3. Square root of 4 is 2. And then I. Good. Okay, I need to pause my video really quick. I actually will be stopping it and just making a second video. So they're going to be a part 1, part 2. This is the end of part 1. My family needs me for a minute and I will be back in just a second. So watch the second video. Thanks for watching.